Okay, so now that we have learned what integration is, let's learn some basic techniques for integration in algebraic aspects. So really quickly off to the side, whenever you have an integration question that gives you a graph, you might have a graph like this. There's nothing too complex to it. You'll usually just have to use different formulas for 2D objects like a circle or a square or trapezoid, and you just have to calculate this area under the graph. But here's something to note down when you're doing this based off graphs. If you're given an area that's underneath the x-axis, you have to make sure that area is negated. If it's above the x-axis, it's positive. So if you were to take this area right here, this is a negative area because it's below the x-axis, which means if you were to add this area, this negative area to the positive area, then you'd get your actual integral from this point right here to this point right here. So that's just a quick tip to keep in mind. So now that we have established that, let's dive right into some basic techniques. The most common one you're going to see and use is going to be the power rule. Let's say we have a function f of x is equal to x squared. Well, the integral, let's go without bounds for now, is going to be x cubed over 3 plus c. So I'll talk about the plus c in just a little bit. But how do we get this x cubed over 3? So let's say we're given a function f of x is equal to x to the nth power. If you want to integrate this function from bounds b to a, you can rewrite this integral as x to the n plus 1 divided by n plus 1 from b to a. Now, if you're not given bounds like we are in this problem above, you'll have plus c that replaces this b to a. But once again, we'll just talk about this a little bit later on. So this is going to be one of your most basic rules, so just keep this in mind. Maybe write it down on a piece of paper or something and look at it every time you're doing an integration problem so you memorize this really, really quickly. You'll use this arguably in every integration problem. Well, not every, but like, 80 to 90% of integration problems that you actually use. So we'll do a quick example that's different from the one over here. Let's say we're given f of x is equal to 6x squared. What's the integral of this function? Well, integral of 6x squared, we'll ignore the plus c for the time being, but what is this integral? Okay, well, we can rewrite this x squared. Whoops, let me just get rid of that little line there. But we can rewrite this, we can bring the 6 out of the integral first of all, actually, and we'll talk about this more when we go on into integration rules and examples. We can rewrite this as the 6 times the integral of x squared. And we know from this problem that the integral of x squared is x cubed over 3. So this just becomes 6x cubed over 3, or 2x cubed plus c. Now, how do you know this is the integral? Well, if you were to take, let's call this function g of x, we'll say 2x cubed plus c. If you were to take the derivative of function g of x, what do you get? Well, using the power rule that you've memorized for derivatives, you just get 6x squared. And as you can tell, these are the derivatives and integrals of each respective function. Okay. Now, next video, we're going to continue covering some basic integration techniques. We'll learn how to account for the chain rule. The chain rule is basically, if you have this sort of function, you have to account for this being a function and the entire thing being a function. How do you account for that when you're taking an integral? We'll cover that in the next video. So, before we do that, let's really quickly talk about some basic integration rules and examples. And these are at the most basic level of integration. So we'll establish a couple of functions here. So we'll have f of x, g of x. These are going to be two functions, and let's say we have a constant L. Now the L is going to be a different constant from c, so just keep that in mind when you're following these rules. So your first rule: if you have the integration of two functions being added together, you can split this up into the respective integrals of the individual functions. So the integral of f of x plus g of x is going to be equal to the integral of f of x plus the integral of g of x. Now the bounds have to be the same. If your overall integral is from a to b, or b to a, the bounds for each individual integral also have to be from b to a. Otherwise, it's not proper calculus. It's basically mathematically incorrect. Now this also applies for subtraction, so I'll just go with a plus minus here. The next rule. So b to a of f of x times or divided by g of x is not equal to the multiplication or division of the respective integrals. Now I'm not going to explain this too much. If you want to go through an example, feel free to do so. You can try taking the integral of 5x squared times 6x. I'll just leave that there as an example, but this does not apply, so that's also important to note down. It applies only for addition and subtraction, not for multiplication and division. Another rule we'll cover is if you have an integral of some function multiplied or divided by a constant. So, let's say L can be either 5 or L can be 1/5. So regardless of whether it's being multiplied or divided, you can rewrite this integral as that constant times the integral of the function itself. So this is the rule that we applied when taking the derivative of 6x squared. And that's why we're able to move the 6 outside, because this rule applies to any integral that's being multiplied or divided by a constant. So if, let's say if this were instead the integral of 1/6 x squared, we can rewrite this as 1/6 times the integral of x squared. So the same thing applies there. Now these are the three basic integration rules we're going to cover, and I'll go through a couple examples of, well, we already established an example for number 3. So let's go show or display the first one. Let me make some space over here just so we know what we're working on. Okay, so if we have the integral of x squared plus x cubed from b to a, and just keep in mind you can check your integrals by just taking the derivative of them, since you already know the derivative rules. If you take the correct derivative, you should get your antiderivative, which is the function that's being integrated. So we have integral of x squared plus x cubed. Using our rules, we can split this up into the integral from b to a of x squared plus the integral from b to a of x cubed. And now scrolling back up to this power rule over here, we can integrate these, and this becomes x squared plus or over 3 from b to a plus x to the 4th over 4 from b to a. So leave it as is, but let's go ahead and check this. If we were to take the derivatives of these respective functions right here, so we have very limited space here, but f of x is going to be equal to x cubed over 3, and g of x will be equal to x to the 4th over 4. So taking the derivative of both these functions, you're going to get 3x squared over 3, which just gets you x squared, plus 4x cubed over 4, which just gets you x cubed. So this becomes x squared plus x cubed, which, as you notice, is the same as the original function over here. So I don't have time to go over the multiplication one, but now that you know the basic format of an integral, you can try to do this on your own.